First of all, Eric Pratt is an EV specialist.
Mhm.
Can I call you that, Eric? Okay.
Well, yeah, I'm not sure if I would term myself that. How about a oh gosh, a person with expertise?
Okay. That to me, that's an expert.
Okay.
All right. You will address your presentation with the pros and cons, misconceptions, and what to look for or avoid in electric vehicles. You're welcome an information exchange to set the record straight about the technology and any issues that you can think about. I'm sure that if Eric doesn't know the answer, he'll find it and probably get back to you or to us all at a future date. Let's see. Eric and his wife Susie have driven EVs since 2016, indulging a decades-long interest in renewable energy in the built environment. They currently drive a Bolt EV for their around the Metroplex car and an Ioniq 5 for longer trips. Eric has served as secretary of NTREG, an education and advocacy nonprofit, for the past 6 years. He earned a BS in mechanical engineering with a focus on energy and fluid systems at UT Austin, then worked 32 years as an aerospace design engineer, developing mechanical and hydraulic components for commercial and military aircraft. But now he's come to ground with the EVs. So, Eric, do you have any questions for us before you launch into your topic?
Gee, are there many electrified vehicles such as hybrids or electric vehicle drivers in the group? I see Randy Boys, I see is one. I know Dick is one.
And we would love to be, but we have two vehicles that are, one is 19 years old, the other one is 21 years old. And we haven't been able to afford an EV yet because we like to take long trips. And that has been the driving range of the batteries has been an issue for us. We don't want to spend half the trip charging. So I'm sorry, Eric, I have a bunch of questions to ask you later, but I want you to get started.
Okay.
Don't let me keep you anymore.
No, that's fine. Let me go through the slides fairly quickly. The first one is pictures of our EV menagerie over the years. We started out when we moved back to Texas from New York in 2008, and the car that we purchased then was a Prius, which distressed my wife greatly because it didn't look anything like the 1970s vehicles that she had learned to drive as a kid. But we loved the car. It served us very well. But I call it my kind of like my gateway drug to electric vehicles, because the idea of regenerative braking and being able to drive without the gas engine starting was really intoxicating. So in 2015, I broke down and bought a Leaf. And that was our around town car. And at the time, all of the YouTubers and various people giving out kind of advice on how to integrate an EV into your life had the kind of suggestion that, like you were saying, Grace, that if you're a two-car family, you have one that's an in-town car, that's a perfect one to be electrified or to be electric. And then you could use an electrified one, a hybrid, or even a plug-in hybrid for your long distance car. So for some years, we've always kind of kept that in our stable of cars. First, it was the Leaf and the Prius, the Leaf being the round town car and the Prius being the long distance car. When the Prius aged out, we went to the Volt, which is a plug-in hybrid. As you can see, the ranges I've shown there are the EPA ratings. And although the EPA ratings aren't exact in terms of what you'll get, they are a good way of comparing the different vehicles in terms of efficiency. We always found it was fairly easy to get more range than the EPA rating by virtue of controlling how you drive. So we drove the Volt as our both an in-town car and also a highway car. It was a good car, but it had some issues with both mechanical and electrical problems that came up about mid-span of our ownership. And during that time, the Bolt came up as a offer that we couldn't refuse from Classic Chevrolet. Our friend Buzz Smith was a salesman there. He's now the director of the Texas EV Alliance. And so he sold us the Bolt. We traded in our Leaf. And then in 2024, the Volt was getting long in the tooth and was out of its warranties. So we decided, well, let's go all electric and get the Ioniq. And the Ioniq 5 has about the same EPA rating as the Bolt, which looks a little strange from the idea of it being our long distance car, but it also has several features that make it more conducive to being a long distance traveling vehicle. I can go through those if they're of interest, but let me go on to the next slides. If I can get it to go. There we go. Did the slide change there?
Yes.
Good. I turned this slide, might change my definition of electric vehicles. We all know we've been driving internal combustion engine vehicles for a long time, about 100 years. And the magic of the internal combustion engine vehicle is the energy storage capability of liquid fuels. You can pack a whole bunch of energy into a liquid fuel. The downside is to get that energy out, you have to burn it and turn it into heat and then convert that into mechanical motion. A hybrid powertrain is basically a electrified, or it's called electrified vehicle. It's an internal combustion engine vehicle with basically a motor and electric assist. It has a small motive battery, but it doesn't have external provisions for charging the small motive battery. And surprisingly, EVs or internal combustion engine vehicles, there were EVs being developed around 1830. The downside was that the energy storage capability was their weak point. So my definition of EVs, and this is what I've seen in many different groups and sources, sometimes they'll have more than just two types defined as an EV, but really they all fall into these general categories. An EV is basically an electrified vehicle that has an external socket, so you can charge a fairly large motive battery, and the battery is basically the electrochemical storage. It's not quite as compact as a liquid fuel, but you don't have to burn it to get the energy out. And looking at the two types of EVs, there's the battery electric vehicle, which most purists like to say that's the only true electric vehicle. I have friends who say, no, plug-in hybrids aren't an electric vehicle, but they have a large motive battery. They have the ability to be charged from the outside, and then they have the internal combustion engine to drive when the battery is depleted. Or they can charge the battery with the internal combustion engine. So the general categories are those two, BEV and plug-in hybrid electric vehicle. Sometimes you'll see things called an extended range electric vehicle. That is basically well, rather than getting into all their nuances, there are many nuances in terms of what a hybrid vehicle can be, how it can be structured. So rather than confuse that, let me go on to something a little more pertinent. Just wanted to show it's not really a myth or a FUD, but it is a point of great confusion for folks who are not familiar with electric vehicles, is the different types of external sockets used to charge that large motive battery. And as you can see, I've put all the different communication ports and the pin uses, but rather than go through all of them, the main thing I wanted to show on this was that in the United States, there is an understanding in the industry that having a whole bunch of different plug configurations is just not helping the industry. So they're all coalescing to a certain extent on the plug configuration on the right, the SAE J3400. It was originally developed by Tesla, and then Tesla marketed it as the North American charging standard. And it's that and the CCS1, which is on the far left, have been kind of competing configurations for some years now. The CCS1 was used by non-Tesla EVs, and Tesla used the SAE J3400 on their cars. But now they're all trying to standardize to the J3400, and hopefully over time, the other two, for the cars that are now running around with those, the CHAdeMO and CCS1 connectors on them, at least for the CCS1, there are adapters that can be used so that you can still use the J3400 standard. And over time, the J3400, I expect, will become the kind of the ruling configuration. It's kind of like a beta versus VHS situation. And just as a point, I often hear or get the question, can you charge an EV from your 120 volt home power source? And an EV is only looking for electrons. And so if you have a 120 volt, 15 amp circuit, you can charge your EV from that. I equate it more to using the pump at the gas station to fill your internal combustion engine car, or going home and using a gas can and a straw to fill it. You'll get there. It's just the amount of time that it's going to take to get to the state of charge you want will be quite a bit slower with a 120 volt setup. So on to the EV myths and fear, uncertainty, doubt. These are 6 that I came up with as ones that I see on a regular basis and have people actually ask me about or tell me that they were the reason my EV was a bad thing. The first one, not enough minerals are available, and there are several subcategories of that. I'll go through each of those. EVs are dirtier than gas or diesel cars, so you might as well not use them. I'll go through those subcategories. EVs are going to destroy the grid. There's never going to be enough electricity to power them. EVs will always cost too much. They'll never be economical. They catch fire if you look at them the wrong way. And they're going to be so heavy that they're going to crush our roads, and all of our parking structures are going to collapse under them. And I was surprised when a fellow at a conference said that to one of the presenters and said, well, we all know that EVs are 2 and 3 times heavier than any other car. How are our roads going to take it? And I was surprised how nicely the fellow answered his question. All the people in the audience were a little less cordial about how we answered his question. But so taking a closer look at the first one, not enough minerals available for EVs. This is basically false. And I wasn't able to find a lot of information about the transition materials required for EVs specifically, but there are several studies that have been done for looking at a complete transition of the energy system as well as EVs. And all of them draw the same conclusion that the amount of mining required will be reduced dramatically. The study, I have a slide here, the next one, that shows a graphic that comes out to be for the energy transition before the 2050 kind of magic date when we really want to be net zero. They're projecting that it would take only about 300 million metric tons of minerals to be mined per year for the whole transition to a cleaner energy system and EVs. And 300 million metric tons is an enormous number, but we are already mining 8,000 million metric tons of coal every year. And so that's many times the 300 million metric tons number. So we already have an enormous mining capability and also distribution capability to move all that material around. So 300 million metric tons a year is pales in comparison. This was taken from Energy Transitions Commission, which is a group of researchers and companies over in Europe. And they speculated that for a global or forecast for a global annual coal usage, right now there's the 8,000 million metric tons. That's this light gray area. And for the total energy transition, including EVs, we'll need about 7 million metric tons of minerals, not molecules as I've heard them described. Fossil fuels are basically a molecule that we dig up just for the stored energy capability. And I've also added on the percent of the Earth's crust that each of these make up. Steel is quite prevalent, aluminum even more, copper is prevalent, and all of these are available. It's mostly a matter of developing the what do you call it? Gosh, it just jumped out of my head. The supply chain to mine these and bring them in. We're already mining all of these to some extent. It's just that those mining features need to be ramped up. So going on to the other parts of the mineral availability, I've been told many times that my car is a child killer because of the unethical labor practices used to get the minerals. And it's true in one instance, cobalt coming from one country, the Democratic Republic of Congo, has had a history of mining with either child labor or human labor that was unethical in its use. And but that's about a fifth of the DRC production. A fifth is still a big number, so it's something that has to be addressed. But the cry of unethical and child labor never came around until EVs appeared, because cobalt has been used for decades as a mineral for a catalyst in fossil fuel refining. It was used in our phones and our laptops for decades before EVs came out. So it's kind of disingenuous that the concern is suddenly so vehement. And there are sources of cobalt in other countries, they just haven't been developed. And also reading in this NYU Stern report, DRC is working to reform the practices. They're trying to develop a way of making sure that people know if their minerals are coming from ethically sourced mines, and also supporting those artisanal, they're called artisanal small scale mines, where people are doing the work to pull the materials out of the ground. And another thing that's affecting it is that cobalt, even with child labor, is an expensive material. And the battery manufacturers and battery researchers are trying to design it out because of this expense. That was a big push early on with Tesla to reduce the cobalt level to the minimum they could, because one, it was unethically sourced, and also it was very expensive. And now one of the, Dick and I were talking about the different types of battery chemistries that are being developed. One that's become quite a bit more prevalent is called a lithium iron phosphate, which has no cobalt in it. And the materials are quite a bit less expensive to mine and refine and produce. So the cobalt is used mostly in the batteries that need the highest energy density. And I've been told that there's no recycling available. And a friend of my wife's asked me, how are we going to handle all the millions of tons of batteries that are going to be laying around once they're dead? I sent her this information, and I've not heard back from her, but so I'm not sure if she has accepted the answer or is just deciding that it wasn't sufficient. But Japan, Nissan in Japan, the first producer of the Nissan Leaf, understood the idea that there were going to be batteries that would eventually need to be taken out of cars and either repurposed or recycled. So they've worked on both ends of it. They've started the Second Life program where they took batteries out of their Nissan Leafs, and if they still had sufficient capacity in them to be useful, they weren't useful as an EV for an EV because they just didn't have the range that was desired, but they could still be used for stationary storage. And there are applications where they gang them together and use them either for home storage or storage at a factory or even grid storage. But then also, like Redwood Materials is a company that is associated with Tesla. It was started by one of the Tesla founders, and they're one of the few that is actually recycling battery materials now, because they take the scrap from Tesla, batteries that either don't make the grade or have some manufacturing issue with them, and they also collect all the cell phone, laptop, any kind of lithium-ion battery they can get, and they recycle them. And part of the problem with recycling batteries is that we're not really good about getting them back to the manufacturers. I know I have probably 10 lithium-ion batteries laying around the house in old cell phones, old laptops, things that I've used for other activities, for lawnmowers, that haven't gone back to recycling just because they're there and they're not taking up that much space. And I haven't found a place to recycle them yet. So eventually that infrastructure, kind of system infrastructure, will be developed. And at the moment, there's just not efficient or not sufficient waste to support large-scale recycling. There have been companies, startups that have invested a lot of money, but gone out of business because of two factors. One, there wasn't enough battery waste for them to really scale up. And two, when they started developing their systems and their plants, the price of minerals was dramatically higher. And that was because of shortages due to low capacity at the various mines. Well, the mines decided to up their capacity, so the price of the minerals dropped, and therefore the financial viability of the recycling has dropped. So it's kind of a back and forth between the cost of mining and recycling that will lead eventually to recycling being developed on a wide scale. But once recycling is developed, then it's a very safe issue from the standpoint of the country, for the country that is recycling them. They have the ability to use those materials again and again and again infinitely, as opposed to being tied to a fossil fuel wealthy nation that may not have their best interests at heart. So looking at the next larger category of myths was EVs are dirtier than gas or diesel cars, and this is false. They often say that, well, the EVs take so much more energy to manufacture than internal combustion engine vehicles, you might as well just use the fuel, fossil fuels. It's true to some extent that there is more energy required in the battery manufacturing and the EV manufacturing, but it's not true that you have to use fossil fuels. So as industry gets cleaner in terms of its energy use, that complaint will go away, and also the amount of fossil fuels it takes to drive your EV varies dependent on the grid, how clean the grid is. And that was their other complaint, was that the electricity grid is all coal-fired, which was true many years ago, and so they say you might as well just use oil and gas because you're swapping one emission source for another one. But the grid has been getting cleaner and cleaner around the world for multiple reasons. First, it was the transition from coal to natural gas for economic reasons, and also the ability of natural gas systems to spool up and down. Coal-fired plants typically don't like to be regulated up and down as the grid demand changes. So the everything was getting cleaner from a carbon standpoint by the transition from coal to natural gas, and I'll show that in our next slide. But now it's getting even cleaner because of renewable energy. Because now the solar and wind are the cheapest and fastest to put on the grid. This is came from the Federal Reserve Bank. It's based on data from the ERCOT, our local grid balancing authority, and you can see the various makeup of the generation sources that we had starting in 2007. We had very little wind, the same basic amount of nuclear that we've always had, a lot of coal, but a lot of natural gas. By 2007, natural gas had pushed a lot of coal off the Texas grid. And as you can see, the natural gas has been making advances on coal over the years. This data ends at 2023. And also wind and solar PV have been making gains, but you can also see from this graph the amount of extra energy that we're using now. In 2007, we used 300 terawatt hours of energy. Here in 2023, we're almost 50% more, up near 450 terawatt hours. But a lot of that has been produced now by wind and solar, with natural gas taking over for coal. I just put on the Winter Storm Uri line here. This is when Winter Storm Uri hit us, and we had the rolling outages. And our illustrious governor of Texas was saying how wind and solar were the reasons for everything to fail. Well, the largest producer of power at that time was natural gas, and it was the main one that failed. I have that in another, I didn't put that in this, but just as an aside, it was the main one that failed in that situation. But now, just as a point of interest, see if I can show my cursor there. Here at Winter Storm Uri, this is the amount of energy developed, but at that time we had about 5 to 6 gigawatts of solar photovoltaic on the ERCOT grid. Today, out in 2025, ERCOT's reporting that we have 32 gigawatts. So solar in the next few years, this purple line is going to be expanding at an incredible rate and supplanting a lot of the energy that was being supplied by natural gas and coal. And this trend is playing out around the world. This was a slide to kind of show how you can compare like an EV to an internal combustion engine vehicle based on the cleanliness of the local balancing authority. The Union of Concerned Scientists has put out this chart for several years. I forgot when they started it, but they've been updating it. And this is the most recent data they had was for 2022. The ERCOT grid has gotten a lot cleaner, as you can see, from 2022. But even back at that point, a internal combustion engine car would have to get 82 miles per gallon to be equivalent, to have equivalent low emissions to an EV charged on the ERCOT grid. And this analysis looked at lifetime emissions with considering the manufacturing emissions and then the emissions of operation. And they say the average is about 94 miles per gallon, because out in California, their grid is cleaner than ours. They're showing about 137 miles per gallon equivalent. And New York is the cleanest, apparently, with 219 miles per gallon equivalent. I think upstate New York gets quite a bit of its energy from Niagara Falls and from what would you call it, hydro generation. So another one that EVs are dirtier than gas-powered cars that came in about 2 or 3 years ago that really surprised me was an article that said that the tire wear on an EV is so excessive that, and they put down that it would be 1,850 times worse than a internal combustion engine vehicle. And going back and looking at the actual study, it was done by a company called Emissions Analytics in Europe, and they were doing they were looking more at the tire wear versus the particulate pollution from the engine. So they were comparing an internal combustion engine vehicle to itself. And they found that in Europe, an internal combustion engine vehicle, the tire wear was actually a greater source of particulate pollution than the engine. But also in Europe, they have much stricter standards for particulate pollution. They actually have to have particulate filters on their exhaust systems. So this number is tied directly to Europe and to internal combustion engine cars. It has nothing to do with EVs. But somebody decided they saw that number and thought, oh, we'll just write an opinion that says that EVs are that much dirtier. And unfortunately, that's now all over the internet, and the myth is still persisting. But if that were true, I don't know how my car would be able to go down the street without having its tires just wear off in front of my eyes. And it is true that EVs will probably have a little bit more particulate pollution than an internal combustion engine vehicle from the tires, just by virtue of being a little bit heavier. And EVs are a little bit heavier. I have a slide about that. But it's not 1,850 times. So we don't have to worry about being engulfed in a fog of rubber particles. And this is a good one that my young neighbor came across the street and told me that my EV was going to destroy the grid. And she was a high school student, and I was really surprised that she said that. I had to try to tell her a little bit about how EVs can actually help the grid. And the grid is a very complex energy balance. This is just the very basic equation. I don't know how much everybody knows about how the grid works, but you have to have a balancing authority that will monitor consumption and bring in generation to meet that consumption. And that's what ERCOT does for us. They're the balancing authority. They usually keep a certain amount of generation over what the consumption, the forecast consumption and the actual consumption is, so that if a generator falls offline or there's a sudden spike in energy consumption, they can handle it. And that's how the grid has been run since it was first developed 130 something years ago. Typically, the generation would try to stay just ahead of the energy consumption, and there wasn't much control of consumption except in extreme cases when very large users were asked to get off or reduce their consumption. But we can control both sides of this equation. We have that ability, and that's one thing that we want to do with renewable energies, which are weather-dependent generation. We want to try to match our consumption to generation when possible, so that we can have the cleanest energy to charge either our EVs or run our grid. And with new modern control systems, that's getting much easier to do, as opposed to what I do now is I'll watch what is going on with the grid. And if I see that the spot price of electricity has dropped dramatically and solar and wind are strong, I'll run out and plug in the EV and charge it up, which is a little bit of a way of doing consumption matching to the renewable generation, but it's not a convenient one. And if we try to stay with the old model of having generation try to meet our energy consumption, we're going to have an extremely expensive grid, because we're sizing the grid to meet the demand of the worst point in the year, which really doesn't make much sense. And when my neighbor said that EVs would destroy the grid, I told her, well, it's not likely. It is possible if everybody decided on the hottest part of the day to run out and plug their EVs in and started charging at a high level, or ran down and hit the local DC fast charging, and you had millions of EVs get online, you could probably take the grid down. But that's not likely to happen, because that's what would happen with our HVAC systems. If they all ran the compressors at the same time, we could bring the grid down. And that's why one of the major loads on our system now on the hottest part of the summer. But EV batteries, which are huge batteries, or EVs, which are huge batteries on wheels, can also have new roles on the grid with a bidirectional charging capability. There's these acronyms are vehicle to load, vehicle to home, vehicle to building, vehicle to grid, or vehicle to everything is often used. There are about 378,000 EVs registered in Texas now. And from the Department of Motor Vehicles, there are 26 million vehicles registered, but that's total of light-duty vehicles, heavy-duty vehicles, fleet vehicles, motorcycles, all types of things. And this is primarily light-duty cars, the 378,000. But even at that, I did a quick estimate of how much battery that is that's rolling around in Texas, and it's at least equal to or greater than the batteries that we have as stationary grid storage on the ERCOT grid right now. So even using a small portion of it as batteries for the grid through a vehicle to grid system would be useful to the balancing authorities. And just to go over, I'm not sure if everybody has seen the ERCOT data that you can get. This was May 25th, and it was a nice sunny day with fairly strong wind. And ERCOT gives us all this information each day. There's what they forecast the load requirements will be. They give us what the actual requirements were. They forecast what generation they'll have available, what the actual was, and this is what's available, and this is what's been committed. This is generation that's already said they will participate in the market that day. And so you can see with this has a step up, which is the solar coming online in the morning. And then it has a drop when the solar drops off in the evening. And in the winter, there will be a kind of a choke point here. And typically in the summer, there's a choke point here when we still have high temperatures and the sun drops off. In the winter, it's that the sun hasn't come up and everybody wakes up and starts heating up their house and their coffee in the morning. And that's where we need some type of storage to get us over those choke points. You go to the next one is the 6-day forecast for that same day. Here's ERCOT's forecast based on weather and the day of the week, what the generation requirements will be, what the demand will be, and this is what generation will be available. And here's one of those choke points where there's potential for needing something other than just solar and wind. Natural gas may come in there, or batteries are coming in there on a more regular basis now. And I put in here, this was the 2023 Texas peak demand requirement of 85,500 megawatts. That's still the maximum that has ever been drawn in the ERCOT grid. And I wouldn't be surprised if we surpass that this year. We didn't surpass it last year. We got close to it, but we might surpass it this year, depending on how hot the summer is. Oh, let's see. But you can see that this is with the amount of solar that we have on the ERCOT grid. It has this very nice increase in generation that gives us enormous margins, or can give us enormous margins during the day. And if we are just a little smarter about charging than going to the worst time of the day, then we will have definitely enough energy to charge our EVs. Another myth is that the EVs will always cost too much. And it's true that at the moment, EVs do have a price premium over internal combustion engine vehicles. Right now, the data I found was that they're saying they're about 12% more than cost 12% more for the average EV than the average internal combustion engine vehicle. That was Inside EVs, and they were citing data from a company that looks at around the world, JATO Dynamics. But it's a supply chain issue. It's not an issue of the complexity. EVs are mechanically far simpler than internal combustion engine vehicles. You'll often see they say there's a fraction of the number of moving parts, and it's important to recognize when they say moving parts, they mean the parts that are either spinning or, like in an internal combustion engine vehicle, that's the cylinders moving up and down, the valves, various things like that. Those are all the moving parts which wear and require maintenance or lubrication. In an EV, those numbers are very small, but an EV could have the total number of parts be quite a bit higher than an internal combustion engine vehicle. The difference is that they're all very simple parts. Usually they're in the battery system, or they're electronic parts, which are quite reliable, or can be quite reliable depending on their design. And also they're stationary. And the temperature ranges that an EV sees are dramatically lower in terms of operating temperatures than the parts an internal combustion engine will see. In China, EVs are nearing parity with internal combustion engine vehicles right now. There's a huge number of startups building EVs in China, about 100 different companies, but only a few are actually expected to survive. And they said, the last I read, they're seeing a lot of companies merging to try to get their production numbers up and keep their costs down. But it's a real cutthroat environment right now on the China market. But also they have very cheap EVs. They have a highly developed supply chain for the battery materials and for batteries. And there are incentives from the government, although I think the government has actually even stopped or reduced their incentives significantly because EV adoption has taken off so quickly. The manufacturers in the United States are trying to keep up to some extent and trying to get over that hump of manufacturing kind of the supply chain issues by having more EVs in a different models with a greater price range of EVs. You can see that Chevrolet has now produced the Equinox and the Blazer EV, which are still not inexpensive cars, but they're not quite the price premium that are showing up for the average cars. The average they were showing up here was in the high 40s and low 50s. And the Equinox and especially the Equinox is below that. It's in the mid 30s. And to just illustrate the supply chain issue, China many years ago understood that being tied to companies for either gasoline or oil was not good was not in their interest as a nation. And so they started really working on renewables and EVs. They have a lot of coal, but they also had horrible air quality issues. So they've been working very hard on renewables, the supply chains for solar and wind, and they're also working hard on nuclear. They're still building more coal plants, but I think the projections are for those to start shutting down or to not even be built. But you can see here that China is in red. If I can get my cursor to show up, I had highlighted China here. And in each of these, the mining, material processing, cell components, battery cells, and EVs, China are the red bars, or the red portions there. They're not quite as dominant in the mining of lithium, nickel, and cobalt, but they're dominant in graphite. In terms of material processing, they're dominant in lithium and cobalt, and they're the only game in town really in terms of graphite. And graphite is used in the anode of the battery. The lithium, nickel, cobalt are used in the cathode of the battery. China is dominant in the cathode cell production or cell component production, and also the anode production, and they're dominant in the battery cell production and in EVs. So they have developed the supply chain and they're reaping the benefits of it. And nations that that don't want to be tied to them from a production standpoint are going to have to develop their own supply chains, or in country or with allied nations. This is a fun one that I'm always told that my EV is going to catch on fire. And actually our Bolt was under a battery recall for a potential for a fire. The Bolt had a very good record at the time in the 2020, early 2020s. The Bolt was one of the few that hadn't had a battery fire. And suddenly one day I started reading stories of Bolts going up in smoke. And at first they said it was just because there was an error or a problem with charging. And finally they figured out it was a manufacturing problem. And to control that risk, they told us just limit your state of charge to 80%. Don't charge over 80%, because all the cars that had caught fire had charged up to 100%. And we're sitting on the battery or on the charger. I think there was a case where one had just been taken off the charger and it caught fire. But about, as I recall, it was either 12 or 14 bolts burned out of 140,000 that had been produced. And they changed out, we just followed that 80% rule and never had any concerns. It restricted our driving a little bit because we couldn't use the full range capability of the car, but it was not egregious. And so looking at various sources like the IEEE Spectrum, they looked at Swedish data. Sweden has had a fairly high prevalence of EVs, and their data showed that it was 0.004% of the EV population had had fires, and in their internal combustion engine vehicles, it was 0.08% of the of the internal combustion engine vehicle had fires. And so it's really that all stored energy sources are dangerous to some extent. And we've, over the years, learned how to manage that risk, and we're constantly improving our ways of doing it. I was just showing the various sources of energy that we've had through the years, through the centuries even. Started out with fire. How many fires burned down because, like, these people don't have a screen in front to catch any sparks from a log popping? How many houses have burned down because of improper storage of gasoline? Or how many cars have burned down from aging seals? Natural gas, we still have houses exploding periodically because of a gas leak. I put this one in particularly because I like the fuses as opposed to the circuit breakers, but electrical systems can burn a house down very quickly if the fuse is either the wrong size and you overload a circuit. And we've all seen our cell phones, or seen examples of cell phones that were either new to production or some manufacturing issue catch fire in people's pockets or in their backpacks. So it's all a matter of how do we manage those risks. And with battery storage, we're actually, based on the statistics, quite a bit better at already managing those risks, and those are getting better all the time. Now, the last myth is the myth of EVs being too heavy for the roads and the parking structures. I just put in some numbers for reference of the Ford F-250 can be anywhere from 5,500 to 7,500 pounds. I never heard any complaints about it being too heavy. The Hummer H1, everybody thought it was the greatest because it was such a beast of a car. It was 8,100 pounds. I never heard anybody complain about that. It's true that EVs are heavier than their internal combustion engine equivalents. The data I've found is it's typically between 20 and 30% heavier, but there are outliers on either end of that. Our little Bolt is 3,700 pounds, and these are all empty weights. These are what are called curb weights. And a similar GM product called the Buick Encore, it's basically the same wheelbase, same configuration, same size. It weighs 3,200 pounds, an internal combustion engine vehicle. So our Bolt is 15% heavier. There are enormous EVs now, and most of it is due to the battery weight. The F-150 Lightning is about 6,900 pounds. The Cybertruck's about 6,900 pounds. They have about the same size battery. The Silverado EV is 8,800 pounds, the top trim level. There are lighter versions, but this is the one that has the greatest range. And the Hummer EV is 9,000 pounds. It's a huge vehicle, and it has a huge battery. The battery in each of these is about 50% larger than the battery of the F-150 or the Cybertruck. But it's not like these are outliers. EVs have to stay within the same vehicle weight ranges that our driver's licenses allow us to drive. I have a Class C license, which I expect everybody else does. And that allows us to drive a car that's up to 26,000 pounds or a truck that's up to 26,000 pounds. So, and the designers of the roads and parking garages understand these weights. They've had to design for huge vehicles before. And I don't know that something this big is going to have a very easy time getting around a parking garage. That's one of the things we love about our Bolt. It's so easy to scoot in and out of parking garages and up and down the various levels of it. So basically the truths are, which are harder to find, but they're in the news, that the mineral supply chains are developing around the world, and those are going to have to develop for EVs to become more mainstream. Fossil fuel dependence is a national security risk now for countries with no local sources of fossil fuels or ally-based fossil fuel sources. And if you look around the globe, most of the fossil fuel rich countries, and the United States is one of them, are corrupt countries or are countries that are not averse to using that as a cudgel to get you to do what they want. I mean, so I've heard the European Union gave a presentation, the head of the European Union gave a presentation, said they really thank us for the natural gas that we provided, but they're getting off it because they understand the fossil fuel dependence is a risk to their national security. And I was surprised when an ally had said that. EVs are getting cleaner all the time as the electrical grid gets cleaner and we move to cleaner energy power and energy sources. EVs are supporting the grid now in limited numbers. There are school buses that are being used in pilot projects to support the grid in the summer. Bidirectional charging allows them to do that. And as that capability develops, I didn't put it in here, but one of the things that will help that is wireless charging of EVs. Right now, since you have to plug your car in, it's dependent on the owner to really want to be tied to the electrical grid. But at some point, we'll have the ability to drive our car over a wireless charger and have the settings set up so that it says, "Hello, charger. I understand you're there. These are my conditions. I'll participate in the market." EVs will be part of a circular economy at some point when recycling will be used to minimize the need for mining new materials. Unfortunately, this is an economic balance between recycling and mining. It's like I said before, if you can use the atmosphere as a sewer, it's economical to just mine fossil fuels and burn them without recourse. EVs are statistically less prone to catch fire than fossil fuel vehicles. We've shown that. And battery operational control, the chemistries are getting better, and also the manufacturing and the design of the batteries are getting better to reduce the potential for fires even more. And EVs will eventually replace fossil fuel vehicles around the world. I expect the United States will be a laggard because of our present administration, but it's pretty obvious around the rest of the world. They see the benefits of EVs since they can use locally sourced energy. And this was just the barriers to EV adoption. There's still a lot of work to be done to get EVs to become mainstream. And unfortunately, I heard a statistic that recently they said less than 50% of the people buying cars are interested in buying EVs, that there's still concerns over the range anxiety and charging infrastructure and all the myths that we've gone through already. So one that's easier, maybe not easier to get rid of, but is being worked on to a great extent is the charging infrastructure. Single-family homes are an easy place to put in a level 2 charger. We put ours in 2017 when we first got our Leaf, and it's been a wonderful little addition. It makes it easy to charge up whenever we feel like we don't have enough range. Multifamily dwellings are more problematic. I did a search online to see what multifamily dwellings, if there were any available, and they all just have like a switch. They said, yes, we have EV charging, or no, we don't have EV charging, or they just don't advertise it. But they don't say how much EV charging there is, and I couldn't find any good data about how much it's really available. Workplace charging is a wonderful thing. If we can get it to be adopted more. Out at my wife teaches at Weatherford College, and they put in charging on the campus, not so much as workplace charging, but just because they wanted to have charging available for the community. But it basically gave her workplace charging, and she and several other professors use it on a regular basis. Time of use charging, it would be helpful to incentivize people to charge their EVs when the grid isn't stressed. Time of use would be like free nights and weekends. There are other time of use plans that are used in other balancing authorities. A friend of mine in New York lives in Brooklyn, and their time of use is from noon till 8 p.m. They have their highest rate, and from 8 p.m. until noon, they have their lowest rate. 8 p.m. at night till noon the next day, they have their lowest rate. As more retail electric providers start offering a financial incentive to being given limited control over that charging, the timing of EVs can be reduced in cost and also reduce pollution. One company that does this is Octopus Energy here in Texas. They started in England, and they've are quite dominant over there now, but they're making inroads here in the ERCOT grid. You can get a much lower, not dramatically lower, but like a 15 or 20% lower energy charge from them if you give them either access to your smart meter, your smart thermostat, or to your smart EV charger to reduce the charging, either like with the EV charge at a time when the grid is more capable of handling the charging and the prices are lower. And you put restrictions on that as to when you need that vehicle charged. And they have the same type of thing if you have a smart thermostat. They'll look at your thermostat and say, gee, if we could go up a half a degree now and keep your thermostat from running at the same time that your neighbor's thermostat runs, we can keep the draw on the grid down. And so they adjust the thermostats just slightly to try to balance out the load to match the generation. And as I showed earlier, the EVSE connector standardization is a must to help people not have both range anxiety or adapter anxiety, and be able to basically go to a charger and know that they can charge up just like we can with the charging station. And that's all I had for the formal presentation. What questions can I answer?
I'm going to start with hard ones because I know absolutely nothing about engineering. So please forgive my total ignorance. But why don't we have solar panels on cars?
There you go.
Well, it's a reasonable question. It's been asked by a lot of people. The issue is the even though the sun is pretty hot, and we feel the heat on our skin, the amount of energy actually coming down is fairly diffuse. If you put solar panels on top of the car, they will gain energy. It's just that in terms of the efficiency of the cars right now, it's not enough to really give you a dramatic increase in your range. There are some very specialized cars. One is called Aptera, which has a carbon fiber frame. It looks like a tadpole to some extent. It's three-wheeled, so it minimizes the rolling resistance. It's made to be extremely efficient, and it has solar panels on it. And I think they say that they can get like 35 miles a day of sun. But the issue is more how much energy we like to use and how much energy you could collect in the space that you could put solar panels on the car.
Okay, is that
Does that
something
make
that
sense?
maybe technology will be able to get better at?
It will, but it's right now solar panels can convert about, I mean, the best solar panels convert like
21%,
23,
isn't it?
yeah,
21?
24% of the sun's energy into electricity. And if were some speculations for a thing called a rectifying antenna, but they haven't been able to make it work with light. There was some speculation that they could get much higher levels of conversion to electricity. But even then, the solar insolation coming down on a square meter of the Earth is about 1 kilowatt of power. So if you were able to convert all of that for 1 hour, you'd get 1 kilowatt hour.
Mm.
And a square meter is about 11 square feet. So it's like the roof of your car. So if you could get a kilowatt hour um, based on a car, if it's in full sun in Texas, you'll get the equivalent of about 5 hours or 6 hours, depending on the time of year. You can get upward of 7 hours of equivalent to full sun generation. You could get 7 kilowatt hours if you could convert all of the sun. So it will get better over time, but if you get 7 kilowatt hours, that's depending on which car you're talking about. Like our Bolt, we get about 5 miles per kilowatt hour. That's about 35 miles. So it's not insignificant. But if you're talking about a pickup truck, which gets about 2 miles per kilowatt hour, you're only talking about 14 miles. So it's
Okay.
it's possible, but it means getting much more efficient in our use of the energy that we collect.
Okay, another ignorant question. Why can't we combine solar power with the motion of the wheels of the car as they're turning, the tires? The tire rotation produces energy. Can that energy be captured and converted to propel a car?
Well, no, because then you'd be violating what's called the second law of thermodynamics. The tires
Remind
are
me.
sorry, the car, if you look at it, has energy of motion as it's driving down the street. The wheels are turning because of the friction on the ground, creating a moment, turning them about their axle. So if you try to take energy off of those wheels, you're actually braking the car or putting a brake on the car. That's basically what your brakes do. They um, take the energy out of the wheels, and thereby they take the energy out of your car when you slow down. And if you were able to do that, you'd basically have a perpetual motion machine. If you took the energy out of the brakes and put it back into the car, you'd have to have a something that would violate the because in the second law of thermodynamics, there are no perfect conversions. Everything loses energy in some way, and so the how to describe it. gosh, you just can't take the energy out without having another source of putting the energy in. And so with solar, you can offset some of the energy loss, but you're not going to be able to offset all of it. And you can't really take power off the wheels because then you're just basically applying the brakes. And it's in an electric vehicle, regenerative braking is a way of taking the energy off the wheels and putting it back into the battery.
Yeah.
But you don't get it all back. There's energy loss in the aerodynamics of the car. There's energy loss in the heating of the tires. There's energy loss in the electronics of the car. There's energy loss putting it in the battery and taking it back out. So you never get it all back. You're always having to make up some for the energy losses. But
Okay.
regenerative braking is one of the benefits of an EV in that you don't have to use friction-based brakes to try to take the energy out of the car. You can gather that energy back up and put it in the battery for use when you take off again.
How does that work? I mean, I know this is EVs all have regenerative braking, and it captures that energy instead of wasting it.
They don't all have it. Micromobility, like e-bikes, typically don't have it, but almost all EVs, cars size EVs will have regenerative braking now, unless it's some of the older conversions, the systems didn't have the capability of doing regenerative braking, but they basically turn the motor into a generator, or in some cases, like the Prius, actually had a generator in addition to the motor. It was part of the mechanical transmission system, but they turn the motor into a generator and uh, basically capture the energy of motion in the car that's stored in the car and turn it back into electricity and put it into the battery.
Yeah, that's what I was hoping for more. If
But
more
and
of that energy could be recaptured and reused for a different function.
oh sure, yeah, and the regenerative braking will I've seen numbers say it's like 25-30% increase in range because you get back about 25 or 30% of the energy. I've seen others that were higher, but I'm not sure if I trust their measurement techniques.
Um, Stop me anytime. But
No.
what about um? Okay, all EVs have certain battery lifespans, after which they cannot be recharged anymore. So at that point, if the rest of the car is in good shape, can't you just replace the big battery with a new one?
You can, although right now the batteries are proprietary in terms of their design, and the battery management system has to be able to handle that battery. But they're finding that the batteries actually don't ever haven't degraded yet, unless there's a short or a catastrophic failure in the battery where it won't take a charge. Um, I have a friend whose battery is doing that. I think he may actually be on the call. Um, but most of the time, the batteries just lose their capacity for holding energy gradually. So um, a lot of the warranties are set up such that at 100,000 miles, you can get either 100,000 miles or the battery has to have at least 80% of its original capacity. So they don't really fail typically in a catastrophic fashion. They just degrade a little bit, and you just don't get quite the range that you had when it was brand new. It just means you charge up a little more, and
Is
that's what
it
we
always a
found.
question? Okay, I'm sorry. Is
Go
it
ahead.
always a question of range, or is it just like oomph, get up and go, and acceleration power?
Well, it's actually both. It's mostly range though is where it shows up,
Mm.
because usually it doesn't affect your acceleration power that dramatically. Um, but I mean, having a huge nickel manganese cobalt battery uh, gives you an enormous amount of power. The Tesla not the Cybertruck, but the Tesla Semi has an enormous amount of power capability, not because they really need it, but just because it came along as a benefit of having an enormous battery. But some of it is related not to the battery capability. A lot of it's related to the electronics. So there are different it's a balance of the design. I know one fellow who had an early model Tesla, and he wanted it upgraded, and he wanted to have the fastest capability. They didn't change the battery; they just changed some of the electronic components to give him greater capacity to use what the battery had available.
Okay, well, we're on the subject. What about servicing your EV? How difficult is that? Do you always have to use the dealer?
You don't have to, but the servicing of an EV, there's no oil changes. There's very little brake servicing required because of regenerative braking. At least if you don't mind using regenerative braking. There are some people who don't like using regenerative braking, so they keep it minimized. But I love regenerative braking, and so does my wife. So we have it at the highest level we can set it. So there's no brake maintenance. The coolant system, they recommend replacing the coolant after 100,000 miles. Coolant systems don't on an EV don't see nearly the temperatures that an internal combustion engine will. An internal combustion engine vehicle will have oil temperatures of like 230, 260 degrees, and coolant temperatures up above, right at or above boiling. So 212, 220. An EV, the coolant, they like to keep it down I haven't seen specific numbers, but in the 100-degree range. You don't want your battery to get terribly hot. That's where the energy storage capacity starts to degrade.
Okay, I'll keep on going. I'm sorry.
No, I was going to say there's really not much other maintenance. I mean, our EV, we check the tire. I check the tires, make sure the pressure levels are good. I fill the washers, and I take it in for inspections, for safety inspections. Although now, since Texas doesn't require safety inspections, I don't think we have to take it in for anything. And periodically, I may take it in for maintenance if there's something recommended, but there really isn't much you have to do with an EV from a maintenance standpoint. That's one of the big savings.
Well, and the tires are normal tires? Or are they
Yes.
special in any way?
No, I usually want to look for what's called a low rolling resistance tire, which oftentimes that means it's a little shorter sidewall. They look a little sportier because that means the tire doesn't compress as much and you don't put as much energy into the tire. So they give a little stiffer ride, but they're a common thing. I think Toyota puts them on the Priuses, so they're widespread. It's not like it's a tire that's unknown in the industry, and they're being developed even more now. One of the things I saw that they're trying to do is to make a quieter tire, because EVs, since there's not the roar of the engine to listen to, they inside the car, and that's one thing on our Bolt, inside the car, the thing you hear mostly is the noise from the tires. And so they're trying to develop tire patterns that are quieter.
Oh, how about that? I'm sorry.
Sure, no, it's fine.
Okay.
Willing to go as long as you are.
I want to know about portability. Would it be, I know well, you think I'm crazy, but like some big trucks have a second gas tank. Would it be possible to have like a little trailer or something where you can have a second battery?
It is. That's a good point. And people do that. There are some folks who have built battery trailers that they put on. They can't really plug it in to charge the battery while they're driving, but they may use it as a stop. I've seen for big trucks, one of the things that there is talk about doing is actually putting a battery under the trailer. instead of having a tractor with an enormous battery, what they do is they have a tractor with a battery that can get them the tractor where it needs to go, but then put the battery in the trailer. The only thing is that means it's not compatible with diesel powered trucks. So it's kind of a mix and match issue. You would end up having to have tractors that are paired with a trailer that has that battery. So it becomes a little bit of a difficulty from the standpoint of logistics. But that is an option, and that's one of the things that has been talked about before. And to your point about using solar, I've seen in Europe, they've been putting solar on the trailers of the tractor trailers, because there you have a huge amount of space available. It's probably not enough to keep the truck going continuously, but it's enough to actually either support accessory functions, like if you have a refrigerated box, or to support just increase the mileage between the charging setup or charging times.
I love it. I love it. Okay. One last question about chargers. Is it possible to have a portable charge adapter? So say you need to recharge halfway through your trip, you can go into, I don't know, a gas station or somewhere that has an outlet, a common, AC outlet, and plug in your adapter and charge from there.
Oh yes, most cars come with a often it's called a trickle charge adapter. It's set up it's called the electric vehicle support equipment. It's
Oh,
basically a safety device that you plug into the 120 volt outlet, and it talks to your car and says, "I'm a 120 volt outlet. I can give you this much power," and the car then charges from it. There are versions of that now that can come from various manufacturers that can do 120 or 240. And there's even, I think Tesla may have it. You can go to a campground where they have 240 volt outlets for like trailer hookups,
mhm.
and you plug in there and you can charge up. Some campgrounds allow you to pay a small fee to come use their electricity.
I don't see why not. I mean, it's already there. Are those adapter uh, uh, affordable? I mean, they add a lot to the price of a car?
Well, they oftentimes they'll come with the car. Um, it depends on the car whether they're the 120 or 240
Mhm.
capable. Excuse me, but they often come with the car. I'm not sure. Um, our cars all came with just 120 volt adapters, but I think other friends who've purchased, I think a friend bought a Mercedes, and I think it came with the dual capability adapter. And you can buy them. They're not cheap. They're a couple $100, but they are available.
One last question about Octopus Energy. Is that, uh, tell us a little more about, I've never heard of Octopus Energy. How does that work? Is it like Green Mountain or one of
Mhm.
the other retail electricity providers? And how are they different? Just
That's
because
right. They're just like the other retail electric providers. Like as you say, they're like Green Mountain. I think if you have to look them up in Texas. They don't show up typically. At least I've not seen them on the Power to Choose website.
I haven't either. That's
But
why
if
I'm
you go to
asking.
yeah, if you go to their website, I think you can put in their zip code and they'll tell if they are service your area. And well, I looked at their website one time when I was considering changing, and the only problem I had was our thermostat is not a smart thermostat, and our EV charger was put in way before smart EV chargers were even considered. So it's now, I mean, we put it in 2017, so it's about 8 years old. But smart chargers are all over the place now, and they're quite a bit less expensive than what our charger was. And you have to let Octopus know that how they have to have the ability to talk to your charger, and you give them parameters about when you want the car charged. So like if you come home and you plug the car in and Octopus is your provider, if it's expensive power at that time or it's a bad time on the grid to charge, if you've told them I want the car charged by 5 o'clock in the morning or 7 o'clock in the morning, whenever you want to be able to drive away, and the car will charge itself up to whatever setting you've put at. If you like ours, we set ours to charge to 80% of full charge. Octopus will then watch the grid characteristics, and when the price is cheapest, which is typically when the
The
Randy
demand
just
is down.
yeah, when the price is down, they'll charge your car up, and they'll if so then they'll have it ready when you need it. But you give them the authority to decide when that is, and that's how they do that, by controlling your charger.
Well, given my level of technological expertise, they're welcome to it. I'm going to look into that for sure. One last question. Can the U.S., do you foresee a time when the U.S. can compete with China in terms of supply chain or mining of the minerals we need? Or is it too late now?
No, we could get there. I think it's the Inflation Reduction Act that the previous administration put out was basically an attempt to foster that. They weren't trying to put they put a ban on Chinese EVs because they knew that the cheap Chinese EVs would come in and wipe out our legacy providers. Even Tesla, I think, is, at least my understanding is, they're having a hard time competing with the EVs in China now, because the Chinese manufacturers are so cutthroat in their pricing. But yeah, the U.S. could do it. It's just a matter of if we will. And unfortunately, I think the market around the world is changing. They see the benefit of having electric vehicles, the reduced maintenance, the ability to charge with locally developed power or energy. And I know there have been reports of a little motorcycle manufacturer in Africa. They just kind of started up and started producing their motorcycles, and they have a swappable battery so that their users don't have to sit and charge. And they made little trailers that had a solar array on top, and they put them in various kind of convenient locations in the local city.
Oh, I love
And
it.
yeah, the people would drive up, they'd hand them a few dollars to get a charged battery and give their core back to them. They'd take the charged battery, put it in their motorcycle, go off and do their stuff. Meanwhile, the depleted battery gets put in and charged with solar.
I love it. Thank you very, very much. I'm sorry I've just monopolized your time, but it's fascinating. So much that I don't know, and I probably should know. But I'm going to do my homework with all this information you've provided today.
Well, and any
Okay.
questions you have, my email is on the front slide, ewpratt@mindspring.com. I saw you at the last NTREG presentation on the vehicle to grid.
Yeah.
Keep coming back. We're always trying to email me, or and also keep coming to the meetings. We're there to try to help people understand energy, because we find it fascinating and a lot of people find it terrifying. And so we want to make it more palatable for people to understand it.
You're
Okay.
doing a very good job. Thank you.
Eric, this is a comment from a couple of questions ago from Randy Boyce, just adding to something he said. He said the newer EVs almost all come with the adapters that accept 240 volts level 2 charging, not just 120 volts level 1. The same adapter accepts either. The level 2 charging is 5 to 10 times faster depending on the vehicle type, but still not as fast as the highway style fast DC chargers.
Mm-hmm.
So just Randy had some good comments in the chat. So
oh yeah, Randy is the chair of NTREG. He's the chair of the NTREG board, and I learn a lot from Randy every time I speak to him.
Now, 5 to 10 times faster than what? What is the baseline?
Oh, the 120 volt level 1 charger.
Mm-hmm.
I know a 120 volt charger, since it's typically limited to about a 12 amp draw, it's about a 1.4 kilowatt charge rate. A level
Per
2
hour?
charger, yes, 1.4 kilowatts per hour. So it's about what you would get from a small solar array on your car. It's not very fast. It'll do it. That's why I was saying it's kind of like filling your gas tank with a straw.
Yeah.
It's but if depending on your need for charging, if you're just driving 20 miles a day with your EV, you can use a 120 volt charger at home and not have to put out the cost for a level 2 charger. And the level 2 chargers, level 2, I've seen it used as for a wide range of charging. Sometimes it's defined as, I've seen it applied to like 3.6 kilowatt charging. Ours is a 6 kilowatt charger, but I think the standard can go all the way up to 19 kilowatts. So it depends on the system behind it. And I think most home chargers, I don't think home chargers ever go up to the 19 kilowatts. I think the largest I've seen there was about 11 kilowatts. But 11 kilowatts, you can add a lot of power or a lot of range to your car very quickly.
Okay,
Um,
good. That's all. Those are all the questions in the
Well,
chat.
I'm sorry. Randy also had a comment about wind energy. It's more available at night and cheaper. Is there any way now to pair wind energy with solar power and EVs?
That's basically what the folks at Octopus would be doing. They would be watching
Okay.
your the ERCOT, how much wind is being supplied or is supplying power to the grid, how much solar is supplying to the grid, and they'll try to, because usually when wind and solar are strong, that's when the prices are lowest. And as when Randy was saying, there's a real nice characteristic, especially in the summer, that the wind will be strong at night, and then it'll tail off in the morning, and the sun will be strong during the day. Let me go back. I heard Doug Lewin describe it. He said he wasn't the originator of it, but he called it, you've heard in California, they talk about the duck curve. In Texas, they talk about the cowboy hat curve. And you can see it to a certain extent here, where wind and solar, there's no solar generation in the morning. Wind is coming down from the evening peaks. Then solar comes up, and then it comes down. And there are times when it's a much more exaggerated cowboy hat curve.
Cute. But that's all at the RFP level. There's nothing for the homeowner or a microgrid or some other kind of portable or semi-portable home-based way to pair, say, a wind turbine. How is that battery stored? I don't know. I don't know enough about it. I just want to combine all kinds of renewable energies into one EV.
Oh, okay. Well, you can actually have, I mean, we have a member in NTREG who has a wind turbine. He lives out in Weatherford. I forgot how much, he has 1 or 2 acres or maybe even more, but he has a wind turbine that he built the tower for and put it up on the tower. And he has all kinds of solar. He loves to build different solar canopies and put them up there. And so he's basically off grid. He has a connection to the grid, but he uses it only as his emergency backup. He doesn't ever, he uses it only as emergency backup, actually just to charge his batteries. He never actually draws very much power from the grid. But he likes being independent. He doesn't put power back on the grid. He just likes being independent. And at least I think that's true, that he doesn't put power back on the grid. because he stores everything and he uses everything that he can. He tries to match his load to his production. The only problem with wind generators is that they require maintenance since it's a moving part, and also they get battered by rain and hail, so they will require blade maintenance. They require cable maintenance. They require lubrication. Um, so the nice thing about solar is you buy some solar, you put it out there, and there's very little maintenance required of it. And you can store the energy in the battery during the day. If you have solar on your home, um, or either on your home or on a shade structure in your on your property, you can charge your EV with that power.
Wow. Okay. If I think of any other questions, I know where to find you. Thank
Okay.
you. Thank you, Eric. This
So
has
watch
been
out.
really instructional.
Oh,
Very
good.
informative. Thank you
I
so
hope it's not boring. And
Not at all. Not for me anyway. I I'm surprised. Maybe I asked all the questions people had, but I'll think of more. I know where to find you.
well, that's fine. Yeah,
Thank
and
you again, and
if
give
people
my
don't
love
want
to
to send me the
Susie.
questions, I was gonna say if people don't want to send me the questions, if they want to send them to you, that's fine. If you want to
I'll
aggregate them and send them on,
I'll do
if
that.
I don't know the answer, I'll find one. I'll talk to
Perfect.
Randy.
Perfect. Thank you. Give my love to Susie.
I sure will. Thank you very much.
Thank you, Eric.
Enjoyed
Appreciate
it.
it very much.
I have
Thank you for listening.
I have a
Oh, yes,
question. I have a question.
sure.
Are we going to be able to replace the lithium batteries that we're using now with different mineral?
Mm.
There are lots of efforts to try to do that. Dick and I were talking about sodium batteries before. Um, the trouble with a lot of the different options is that they don't have the density, the energy density that the lithium batteries do. But and I just was reading my news feed. GM has talked about a new battery chemistry that they're describing as lithium with manganese rich. And there's most of the lithium batteries that are the highest energy density are nickel, manganese, cobalt.
Right.
Um, the manganese rich, they didn't say if it had cobalt or nickel in it, but all of the manufacturers, Tesla's been trying to do it. They've been doing high nickel, low magnesium, low cobalt. Now I'm expecting that what GM is doing is trying high magnesium, maybe low nickel and low cobalt, but all of them have trade-offs. And lithium right now seems to be the best from the standpoint of being able to get a relatively high energy density. One of the things that Toyota is working on is called a solid state lithium battery. And the highest energy density battery with lithium is called a lithium metal battery, but it's also the highest fire prone that generates little dendrites when it charges. But if you have a solid state battery that doesn't have the electrolyte, they're speculating, and there's some evidence that it can charge very quickly, have a very high energy density, and be, I don't know if you'd say completely immune to fire, but very resistant to fire. So there's a lot of technologies advancing now that people are seeing the benefits of high energy density batteries, and the supply chains are being developed. There's research going on all over the world. And unfortunately, China is one of the main ones that's doing the research. They are the most interested in maintaining their dominance in that market.
Thank you.
You're welcome.
Okay, Eric, thank you very much. We appreciate it and learned a lot. We still have 15 people on, so you kept everybody going.
Oh, good. I'm glad I didn't chase everybody off. A lot of times I'll have people diving off because I prattle on too much. You're welcome. Yeah, EVs are still kind of a niche item. They're not quite in the mainstream yet, but uh, and there's a lot of resistance to them just because for the energy transition of electrifying everything, which we need to do for climate reasons and just pollution reasons. I mean, the DFW area is now I think I can't remember if we went to extreme, from severe to extreme non-compliance. I forgot how they termed it, but we went one level down in compliance for ozone. And so we really need to go away from fossil fuels to keep our environment clean. And electrification is the easiest way to do it, but it does mean that we have to buy new equipment and new components. And that's a matter of familiarity and education.
Okay, we're getting close to the end of our Zoom
Okay.
abilities, so thank you and have a good evening.
Thank you very much. Good night.
Okay.